Guten Morgen, erste Session, erster Tag, letzter Tag, erste Session. Ich hoffe, ihr seid alle fit, ihr seid aufnahmebereit, habt ja geschlafen genug. Okay. Now I'm switching to English. You slept well. Yeah, you have this first session this morning, and I welcome you to Embeddings, the lesser known hero of AI. Short thing about me. My name is Frank Berger. I'm head of engineering at House 7, which is a label of the B-Factor Chain-Based. Long story. If you want to buy me a beer, I can tell you about it, but it's really boring in the end. And we're a member of the Code 711 network. I started as a Unix system administrator in 1996, and I do Typo 3 almost exclusively since 2005. Obviously, not exclusively because this talk is not really about Typo 3. It's about other stuff, so I have various interests. Come in, sit down. What is an embedding? An embedding is a point in a multidimensional space described by a vector. Vectors in 3D dimensions like height, width, and depth has three numbers, three dimensions. So we can describe where this point in this room is and actually in which direction it's pointing or going. It's a vector that's described with three floating point numbers, basically. What is an embedding? Embedding is an embedding mathematically represents characteristics and meaning of a word, a phrase, or a text. So in this multidimensional space, there is the meaning of a word or a phrase embedded or described. That means it encodes both semantic and contextual information, like synonyms, homonyms, and various other concepts about a word, what you put into the word, what's in your mind, basically. AI and LLMs enable the creation of embeddings with hundreds or even thousands of dimensions. So I can only imagine a 3D dimension, three dimensions, height, width, as I said. Where we live in, I can't imagine a fourth dimension. It's not possible. We can't. Nobody can that. To illustrate what that means, we boil it down a bit to this. So you see on the right side, you see the word apple, and it's pretty close to the concept, to the same concept of the image of an apple. And close to that is a banana, the word banana, and close to it, again to it, is the image of a banana. So you have to think about different concepts, mental concepts, and what they mean, and that they are not the same. The image of an apple is not the same as the word apple, but they're pretty close together. It's pretty much what we want to know. And you see there, because they chose Apple, the company Apple chose an apple as a logo, it's close there again. You can see that that it's obviously something entirely different. It's not the fruit. It's not a thing. They deal in silicon and program code, but it's conceptually, visually, it is in that area. And because of that, for example, Google could be in the same area as Apple, and it's the fruit companies. So there you go. On the opposite side, you have a cat, which is obviously not the same thing as an apple. It's very distant from an apple, but it's the image of a cat and the word cat are pretty close together again in this dimensional space. And we can see as well the step from cat to dog is pretty close again, and from dog to wolf is pretty close again. But from a cat, coming from a cat, going to a wolf, it's a longer way. So you have a feeling of distance between these concepts, between these words. Why is that cool? Any idea? Because we can do math with it. Math is cool. I like math. We can do distance searches with those vectors, and math doesn't care that it's not 3 dimensions or 4 dimensions or 1,536 dimensions. Uh, the math still works. So there's the dot product on the lower left part that's often used in 3D graphics and game mechanics to see in what relation one vector is to another vector by casting a perpendicular line from the shorter vector pointing towards 0, to the imagined line of a long further away vector. That's how you create a dot product. Then above that is the cosine distance, um, which calculates the cosine between those two things where the dot product is embedded. You see the a times b is the same as the a times b on the lower part. And we have more direct approaches to measure the distance, but with the Euclidean formula or the Manhattan formula, which is more like a distance in terms of maps, or if you think of GPS navigation, that's where the Manhattan thing will come in. What we use most in our part is the cosine distance, because um, cosine distance is defined as the distance of of the angle between two vectors normalized to unit length, ranging from 0 to 2. That's in there especially because usually you would have -1 to 1. If you calculate cosine distance, this is cast into a range from 0 to 2. And what we mean with that, if you have a distance of 0 or close to 0, then it's synonymous, the same between those two vectors, between those two embeddings. If it's orthogonal, perpendicular, there's no relation. So if it goes towards 1, there's no relation. And if it goes towards 2, the distance, it's antonymous. It's the opposite. It's cats and apples, basically. The shortest, in our examples, the shortest distance usually wins. And we assume a match everything below 0.1. We are talking about really small floating numbers here. So very, very close match. So everything below 0.1 is virtually the same thing what we're talking about if we compare uh, two embeddings of two words. In PHP, we would calculate this it like this. The lower function is the dot product. Dot product means we multiply two matrices. That means we multiply the first element of the first matrix with the first element of the second matrix, and so on, so on. I know you all had that in school, so welcome back. And the product of that calculation is then summed up, and that's my dot product. And to have the distance, I create a dot product, and the magnitude. Magnitude is the matrix, the matrix multiplied by itself. Um, so I didn't do a second function with power or with squared. I just used the same function because it's in effect the same thing. Take the square root -1. That's the same formula we saw earlier on the screen in PHP. So you don't need NumPy to do that. It's still possible. This will produce a floating point number between 0 and 2. In our examples, we're going to use OpenAI's embedding models. We're going to use the text embedding ADA02 model. The alternative is the text embedding 3 small model. These are two generations. The ADA02 is more like the GPT-3 era, and the embedding 3 small is more the GPT-4 era. In correlation, when they develop that, they create pretty similar results. They both use 1536 dimensions. In my tests, I went back to the ADA02 because it created more consistent solutions for small words, or for single words, for keywords, to compare them, while the embedding 3 is more concise or more logical when you compare it with longer text like a paragraph or two paragraphs, if you want to compare those. And both are normalized to unit length, which is important for most vector databases. We come a bit later to that later. Which means the singular vector point should range between -1 and 1. How does such an embedding look like? This is the word queen. So we see it's an array with a lot of floating point numbers. below 0, above 0, and I cut it down after like 20 because there are 1,536 more of those floating point numbers, which capture the meaning, contents, and relations of the word queen. How do I get an embedding in PHP? I use the OpenAI PHP client, and I I get my text. I open my client, get the OpenAI key. A small hint: if you need really fast an OpenAI key without having an account, just search on it on GitHub. You will find one because people tend to check in their keys. And then we use the embeddings endpoint, create the request. We tell it we're going to use the model text embedding ADA2. We give our text, and encoding is float. The other option would be binary. Some databases require you to save the floating point numbers in binary encoded, in float 32 binary. So you would they give you the option to receive it in binary and save you a step in converting. Then I send this result, get the result back. If it wouldn't work, I would get an exception, so I can be pretty sure that I get the right data structure in there, and that's just a default path to the embedding itself, which then is already an array in that part. Dip cache the resulting embedding. It won't change a lot. Over time, it might change. So if it's like if you want to be sure after half a year or something like, could be new training data, and then you could recreate it. But if you do the same embedding like 5 minutes apart or even days apart, it won't change. So you can save it to your database, cache it. In my examples, I use Symfony Cache, so I don't have to receive the embedding all the time. So let's do math. We take the embedding for monarch, add the embedding of for woman, and we get something really close to queen. Let's try that. I encoded this in this PHP script, and what we get the distance between monarch and plus woman. So really, each element of the vector of monarch is added to the elements of woman, and the distance to queen is 0.08. So we defined earlier everything below 0.1 is really, really, really close. So it virtually is the same thing. It gets into the same directional or range. If we just look at the distance between monarch and queen, it's 0.12, and the distance between woman and queen is 0.1.2 as well, pretty close together. But you see, combining them gets it there. So it's you can really do math with it. It really works. That's the proof we want to show here. It's not nothing you would probably normally do. I can't see an application where you would add two words together to get a second word, but it's as a for the concept, it's something ideal to show. That's nerdy and cool, but what can we do with it? Is that an application? Of course, there's. For example, we can check the quality of translations. That's a fun thing. So I have an embedding class. You can look at that later. You can get the GitHub repo. I take two arguments, text one, text two, calculate the embeddings of those texts, calculate the distance, and say if the distance is greater than 0.125, it's a bad translation. Otherwise, it's a good translation. That's what we can try now. In the translation, I see the moon. Ich sehe den Mond. Distance is 0.08. It's a good translation. Let's try ich beobachte den Mond. So we don't have a direct translation anymore. Still a good translation. Uh, ich Bade im Mondlicht. Yeah, we done creative here with the translation. It's not wrong. It's okay. Bit literal freedom, but it's a bad translation. It's not that good anymore. It's still a good translation, but we're getting far further away. And to illustrate the point, language is not really a problem in that part. It's not. It's only one of those 1,536 factors in there for the meaning of those two sentences. So if I check, my name is Frank, and watashi wa fulanku desu. No, that's the wrong one. That's watashi no name wa fulanku desu. Watashi wa fulanku desu, which is the same in Japanese. We get a pretty good translation. So it works even over more languages, uh, um, through more languages, because the underlying information, my name is Frank, is the same in all languages. Language is only one part of those um, factors. The 10125, that's the threshold defined by us or by me. If you want more literally poetic freedom, if you want more poetic freedom, you have to increase it, and it could still you could still what that's pretty. That's actually an application you could do. You could check automatic check how good are my translations in the database with that, and filter out which are have a certain threshold. Normalize unformatted data. Um, in our business, we often have unformatted data. Everything you have in your TT content is unformatted data. It's not normalized, it's just text. And maybe you want to generalize it, you want to normalize it down to some categories automatically. So what we have, I introduce here a new function, generate directory, which does what I did manually for each of that rock, paper, scissors, lizard, Spock. Will I generate the embedding and put it into a dictionary with the name as the key, the value, the embedding as the value, and then I iterate over it, calculate the distances, and this will be an array which is already sorted from closest to furthest away. And then I return it. Normalize unformatted data. Godzilla, I Godzilla is back again. You see my leaning towards the Eastern fantasies. It normalizes down. You see the hierarchy here. What it read, the input Godzilla is variant is normalized to lizard. That's a pretty good thing. Um, I want to fly to the moon. Any guesses? Spock. It's alien. It's fantasy. It's space stuff like that. Um, let's try another one. I need to buy some pliers. I need some scissors. So it's the same concept. A plier and a scissors, virtually the same concept. So this way you can normalize data. You can automatically create a categorization for data, for product data, for anything, which is just in quotes, of course, text, which is just text there. Okay, photo done. This way we can normalize random data and text to our domain. Our domain is the rock paper scissors illicit right now. Your domain would be like auto parts and fluffy animals, whatever. It doesn't matter. You can categorize it down. What about bias? I mean, we're talking about AI. We have to talk about biases. Let's try a bias, or let's check bias in this embedding. We just can test it. So I calculate a embedding for female profession. I create an embedding, calculate an embedding for male profession, and then I give an array of more than doctor and nurse Um, there are more professions in there. I give the area and calculate the embedding, and then we just check how close it is. Is it or how not how close? What would be the categorization? Is it a female job or a male job? Is it a female connotation job or a male connotation job? You have to remember we are asking the AI here for a binary answer, a yes and no answer, 0 and 1 answer. That's not normally what they deal in, but we force them to. It has to make a decision now. 1 second. I hope you can still read it. I guess. So doctor comes down to a profession for women. Nurse is a profession for women. Pilot is a profession for men. Flight attendant is a profession for women. So we get into those role genders. This works basically in English because in English a noun is not gendered. In German, we would gender the noun often, like Arzt, Ärztin, and that would be a closer correct match for the um, for the gender. But that's what comes out. And I mean, it's not the AI which is sexist here. That a lawyer usually is a man and a paralegal is usually a woman. It's our data. We feed our data in, and our data is the sexist data. Interesting is a web developer is a profession for men, web designer is a profession for women. Assistant is female, secretary is female, assistant to the CEO is male. So you see the bias here. An interesting thing is here the doctor is a profession for women. When I started testing this a few months ago, this was man, this was male. So they still feed data into into those models all the time, and it can change. It can change over time. My theory why it changed is they added the data for GPT-4, which is newer. The GPT-3 data was like 5 to 6 years older, or older. I don't have to remember right now. And in the last 5 years, there was a trend in the USA that more women made their PhD. So more women or more female names appeared in papers and scientific research as the authors, and maybe that skewed that data. With the newer data came in, it skewed it over to be a profession for a woman. It is still close. I mean, 0 2 to 4 and 0 2 to 5. That's a real close match still. Of course, there are both genders here. No, biases are inherent to all AI models, especially the neural network models. It always depends on who and how they are trained. So by who train them and how they are trained, and it is inherent to how they function, biases. They only deal in biases in the end. It's how we interpret those biases, if we think it is a good thing or a bad thing. But a neural network is a bias machine in the end. You have to train into a bias that it sees a sheep in the picture and not a horse. That's a bias. That's something we have to keep in mind when we train models, when we use models, that there and it can affect. Another example for bias is the RAM. In English, what would you associate with RAM? I need three. Memory is very good. A really large pickup truck. And number three, yes, mail sheet. Thank you. So we want to see, we give a text, and we want to see what the embeddings are, what we can calculate. If we are talking about a truck, computer memory, or a sheep, and to pull out the bias here. Um, Forgot how I called it. Oh, the RAM, pretty logical. I need RAM. It's probably computer memory. Yeah, it's a pretty good guess. I need a RAM. Anybody who is for pickup truck? Who wants to buy a sheep? Very nice. You all bought computer memory. Still. I need a RAM for my farm. Sheep, computer memory, pickup truck. It's a pickup truck. You probably need a pickup truck for your farm. But well, I have sheep on my farm, so maybe I would have had need for the male sheep. Um, I need a ram to pull my boat. I have a boat. I always wanted to have a boat. I need a pickup truck again. Um, I need. I didn't think about that. A recipe for a ram or ram? A ram. Still a pickup truck. That's probably you have to repair it. You don't eat it, you repair it. That's a good thing. It's actually pretty hard to get to the sheep. Uh, I need a ram uh, to breed my sheep. I don't want to be incorrect, but it's really hard to get to the sheep. Right. I introduce a new function, get the nearest neighbor, which does all the things I did before in just one thing, and I will get the keyword and the distance back. You can look at that later in the code if you like. Takeaway, models are trained by nerds. And that's not even declaratory or anything. You have to see it, think like that. If you're sitting in Silicon Valley and need to train some models, you take what you have closest to you, so you can verify what the model is creating as output. And the closest to a computer nerd is computer stuff, because that's what they can qualify, what they can use as reference data. And then we talk about the rest, like a pickup truck, that's probably from marketing material, and sheep are probably really far away from that whole thing. Good thing we can use those embeddings, for example, to test the bias in our models, which we just did. So if we have own models with our own data, we can use embeddings to test the bias, to calculate biases, to make biases visible. Another interesting thing, we can do statistical analysis, sentiment or emotion. We can create a list of emotions here, or what the emotion would be. Same, it's getting the same thing. We calculate distances for an arbitrary input, and I have created a dictionary with joy, sadness, anger, and 120 more emotions, which wouldn't fit on there. I create the array with distances, and I do something different now, because we learned binary answers from an AI will give me a binary answer, which I probably not don't like, or maybe not like. So I want to have back everything which has a matching value below 0.25 in my examples. No, no more annotation. No, doesn't be right. No. Yeah, sentiment. Thank you. Okay, sentiment. Um, let's try here. That's one. I was scared of my mind for my first live presentation. Traits: a sentiment, fear, fearlessness, anxiety, embarrassment, horror, disbelief, confidence, courage, exasperation, anger, bewilderment, awe, surprise, excitement, and so on and so on, which is probably a pretty good description for that sentence, or for that sentiment. Um, Try a different one. I love the Type of 3 developer is 2024. I love the Type of 3 developers with sentiments of love, joy, hope, passion, hopefulness, nostalgia, optimism, and excitement. I think that's a very good a resolution to my to this nice sentence. I see you can use that to do some interesting things. More fun things you can do with embeddings. What a few ideas. Maybe I hope you will get your own ideas, and then checking the mood. This is our example how soon Zoom tells how well a conference call went. You have the feature for since like 3 or 4 years that Zoom will give you analysis if there was a positive vibe, a negative vibe in the call, if there was somebody who was very sarcastic, or if a certain one or a certain person always argued against everything. That's done with embeddings. What they do is they do a speech to text and run embeddings on that, and then you get a rating for that Zoom call. Input parser for spoken languages. If, for example, you want to build a text adventure game, somebody should do that again. I really would like to play one. And you want to be very free with it, and want to allow the person to say, "I stroll to the west gate," and it will give you back, "Okay, he's going west, or east, or north, or up, or down." Finding similar products, is more our thing. Finding similar products, closest neighbor, not based on keywords or predefined relations, but loose couplings like the order history or the search history of the person who is looking for it, or other contextual stuff. I mean, I bought a toast on Amazon, and now I get 100 advertisements for toasters on Amazon for Amazon, and I have already, and I don't need one in the next 10 years probably, hopefully. Was pretty expensive. No, it's okay. Creating it, and that's what actually I have that as an example. Creating a search by intention, not keyword. So you index your database, your web pages, your TT content elements. Ideally, each text element basically is a separate embedding, so you get a good sample base. And then you can create a search by intention. It wouldn't match the keyword necessarily or any other metrics, but it could be a good idea to give that result for a certain sentence or certain phrases. Uh, in the same way, in a chat or a chat feature based on your database, on your local database, and not some arbitrary plugin you pull into with JavaScript. So my examples are over, so it's getting going back to the boring part. How to store embeddings. Um, Normally, right now you would use a vector database. These are some products which are vector databases. There are many more. These come up if you search Google or anybody else. Um, Qt Azure, Cognitive Search, Pinecone. Those databases, they have the advantage that you can use other algorithms other than just the cosine distance. They have features like you can create a grouping of embeddings or words which are close together in your database, basically, like a clustering analysis or something like that. They have those functions built in. You don't have to put them in there. Notably, Redis, that's probably what we usually have on our machines. You would need a Redis Stash server or install the plugins into the vanilla Redis server. The Redis Stash server is basically the edition where everything is in the Redis server. You get it as a Docker image as well to run. It really works well. Otherwise, normal Redis, for example, doesn't have a data type for JSON, which is ironic, but yeah. More interesting for us would be relational databases. There is some progress here. Postgres has a extension, the PG vector extension, where you can then store an embedding in the table in a field with a special index and search with special functions. MySQL 9.0 has a vector data type. Finally, and MariaDB 11.6 vector preview, which came out this week, um, will have a vector data type and functions as well. The down thing is all three have different. There's no standard SQL terminal standard how you would query those vector fields. They all have different function names and stuff like that. So either you commit to a certain database here, or you wait until Doctrine has an own layer above that to search for vectors. Or what you can do, you can use a file system cache, what I did for my examples. It works. You can load it into memory or store it on a memory disk, and it would be really fast as well. But of course, the calculations would be in PHP or whatever other language you would do, and not in the database. Alternatives to OpenAI. Some might don't like use OpenAI. Um, I, Olama, does anybody knows what Olama is? Uh, I will describe anyway. The Llama, the second part of Olama, is the LLM released by Meta and Facebook, Meta Facebook. They release gradually their large language model, and you are free to use that. You don't have to buy a license for it, or then you can put it on your server and just use it. And Olama is they tout themselves as the Docker for large language models. You can just like Docker run. You could you type in Olama run this thing, this language model, and it will start up a server, and you can start querying that thing with certain with small data samples and large data samples. It's actually pretty good. It actually really works well, and they included as well other AI models, which are not large language models, which you can run in their ecosystem. And they have 3 embedding models available, which are accessible through a REST API then. Um, the Google Vertex AI has 2 embedding models you can use. I personally, I don't like using the Google API. I'm in war with them or in a constant quarrel, so I didn't test that. But it's there. You can use it if your infrastructure is on Google anyway, or using Google services. Could be a good thing. And please don't ask me why there are different words for Google AIs all the time about Gemini Vertex. I have no idea. I don't think that Google employees know it anymore. And there are algorithm-based models, of course, like TensorFlow, word-to-vec, bias. The principle, the idea of an embedding is actually pretty old. It was defined in 1970. So back then they came up with saying that we want to embed, but we want to have the meaning of a phrase or a word in a mathematically approachable way. Bias, maybe you know, you rely on it because most spam filters use the bias algorithm to filter spam out, to categorize an email as spam. And in the end, below that, it's all an embedding model or something related to an embedding model. Word2Vec is a algorithm which has binaries as well, which you can use, and TensorFlow is a product. So I'm almost done, and I'm in good time. Special thanks go to Barry Stahl, whom I had the pleasure to meet at Kung Fu in Canada, who gave basically this similar talk, and which was the inspiration for my talk right now. So I don't want to take that away. He explained it to me he explained to me what I'm explaining to you right now. Sudo7, my employer, for letting me abuse their OpenAI key, and they actually paid the whole time. I didn't do this in my spare time, which I'm thankful, but it took some time to get all that stuff together. And I'd like to thank the Type 3 GmbH for letting me back on their stage again to talk about weird things again. So thank you for that. And what are your questions? If you want to can. Okay. Now we go on travel because we only have one microphone. Your hand went up first.
Maybe, I don't know. 2 questions, essentially. One is, I assume that everything that you showed has been running on your computer, including the vector database, right? So there's no remote network connection other than downloading the embeddings in the first case. Okay. Oh, that's it already. So I have one understatement problem because when you tell me how embeddings work and how concepts are aligned into the dimensions and everything, and you then input a whole sentence. How and tell the machine to create the embeddings. How does that actually work? Because it has to identify the main concepts in between in the sentence and whatever, and align that to it. This is something which is magical now to me.
Sorry, thanks. Yeah, that's a good question. And I can't really give you an answer because they are trained, these are trained neural networks. And you can't debug a neural network. You can't just, you can only retrain it to give you a different approach. But there are hundreds, thousands, maybe even millions nodes in there which come to the conclusion this is the embedding for the sentence, the grass is green and the sky is blue.
Okay, you showed the example where the embeddings categorize any input to rock, paper, scissors, lizard, Spock. And that is based on the world knowledge of OpenAI because you download the embeddings from them. Now, when I want to use it for my company, I want to, of course, apply our own knowledge of the world to categorize things into our categories. I guess the right solution would be I would need to train an AI with my own business knowledge. But is there a way like to do a cheap post training on the data so I could just feed a little bit of categorization into the embeddings, I guess. So, for example, here are 100 texts and the categories that we assign to them. Now, please consider this when as given any future input. Is there a method to do this, or do I have to train a new model for that?
It's a really good question as well. The the big vendors like OpenAI, Vector, the Vertex AI from Google, they allow you to train your own models. You can basically go in there and say, I want to retrain your embedding model with my data, and you would give positive and negative feedback. Basically, that's how you train a model. If that's too much for you, or you don't want to give out the data, that would be the best way, basically, to have your own model and have it trained to your needs. And it doesn't. You can automate this stuff because you have to sit somebody down and categorize it, but then you can upload it and reinforce the thing. On the other hand, you can use the embeddings how you get it, the way you get them, and interpret the distance or use different algorithms on them to get your solution you want to have, or your feeling for it, what you want to have, or say, okay, we don't want to do this. It's a matter of how you ask it then as well. There's a bit of prompting coming in there as well. Yeah.
So in theory, you could feed and model that you have all your Git repository from your company, and then make embedded check the code for the new people. So the code it looks like our code, so it's not looking like our code, so something like that to check the quality of the new code that came. Yeah, oh, that's nice.
Anybody else? Before there, it could have been a yawn. It could have been a
No,
single.
it's actually a question because um, I guess normalizing vectors really helps with calculations between them, but also when they are getting generated, they include some kind of information. And there's a reason why they have that specific length in the first place. And I wonder if this normalization is actually the reason for sometimes mismatches where a word gets kind of weird. Is that the reason?
Yeah, that's the reason why you sometimes get weird answers, for example, from GPT, ChatGPT or something like that, because they use embeddings as well. ChatGPT needs to know what you mean or what it thinks it means when you ask it, why can't I book a train in Germany? Maybe they have a good answer. I can't. Um, But yeah, they use embeddings as well for this categorization. It's not only guesswork, it is math in below, and you need to do the math, you need something like embeddings for that. So yes, that's the reason. If you have a mismatch, then there's some vector in there or some vector which points in the wrong direction, or not the one you intended it to have.
Thank you for your talk. You have mentioned that you may easily compare two embeddings via your code. Is there the other way around? So you have one reference embedding and find matches which are close to them?
Yes, that's what the Spectre databases come in. When it's Spectre database, right now we would have to do a nearest neighbor search, which means we'd have to check everything, and they have algorithms and tools which says I have this embedding and give me something close to it, everything close to it. That's possible in those vector databases. That's where their selling point comes in, not just the neighbor search. That you can do that in Redis. That's easy there. Yeah. Okay, thank you. I'm here all week or the rest of the day. Under this QR code is a link to the page where the talk is embedded, and a link to the GitHub where you can check out those examples and play around with them. Again, if somebody wants to see more about the stuff I did, you saw my scripts. I have like double the things, and I don't have double the time. Just hit me up. We can sit together. I can show it. No problem. Thank you very much.